Okay, in this video I'm going to discuss unit conversions, and we're also going to talk about conversion factors. So unit conversions often feature one or more conversion factors. So what exactly is a conversion factor? Well, a conversion factor is going to have to do with a relationship between two different units. If you know a relationship between two different units, then you can write a conversion factor as a ratio. Let's take a look at some examples of conversion factors. So consider the following relationships between units. There are 100 centimeters in 1 meter. There are 1,000,000 joules in 1 megajoule. There are 63.55 grams of copper in 1 mole of copper. And for every 12 ounces of liquid volume, there are 355 milliliters. That's basically a can of soda. Now all of these have relationships between two different units, and you can write a conversion factor in two different ways. So for example, for 100 centimeters equal to 1 meter, you can either put 1 meter on top and 100 centimeters on the bottom, or you can flip that ratio upside down, and it still means the same thing. So the question is, when do you need to put centimeters on the bottom, or when do you have to put centimeters on the top? It just depends on the conversion factor that you need and what units you're trying to cancel out. So in a similar way, you could have 1 megajoule over 1,000,000 joules, or you could write that same conversion factor upside down. You could have 1 mole of copper on top and 63.55 grams of copper on the bottom, or you could flip that upside down. You could put 355 milliliters on the top and 12 ounces on the bottom, or you could have it the other way around. So now let's talk about conversion factors and how they're used with specific examples of problems. So here's our first example. There was a man who lived back in the 1930s and 40s, and he had the Guinness Book of World Records for being the world's tallest man. His name was Robert Wadlow, and he was 272 centimeters tall. Let's convert this measurement from units of centimeters into meters. So we have 272 centimeters. What is the relationship between meters and centimeters? There are 100 centimeters in 1 meter. So we're going to write a conversion factor, and as you can see, we have the multiplication symbol, we have a horizontal line, and we're going to put the units we want to get rid of on the bottom, in this case centimeters, and we're going to put the units we would like in our answer, in this case meters, on top. Let's fill in the numbers. So 1 meter is equal to 100 centimeters. Now I can cross out the unit of centimeters, and my answer would be 272 divided by 100, which is equal to 2.72 meters. Now, that problem was not very difficult. So at this point, you might be thinking, okay, Mr. Faribault, that was too easy. I'm not going to set up a conversion factor to simply go from centimeters into meters. Well, the problems do get more challenging than this, and I will definitely show you some more challenging problems. And just to remind you, why are unit conversions helpful? Well, number one, they focus on the units instead of the numbers, and that can help you put things into perspective. They also allow you to do not just a simple one-step conversion, but you can do multi-step conversions. As long as you keep track of your units, it's the same procedure. Whether they have 1 step or 12 steps, it doesn't make a difference. And then it minimizes the risk of algebra and making mistakes with trying to solve for x. So I think unit conversions are very important. I'm now going to show you a more challenging problem. So in this example, we have a cup of coffee, and 1 cup of coffee contains 160 milligrams of caffeine. So if you were to get a 20-ounce cup of coffee at Starbucks, how many molecules of caffeine are present in this Venti cup of coffee? That's a little more challenging. We have a 20-ounce cup of coffee, and let's take a look at the facts. What are the relationships between units that I would need to know to solve this problem? Well, as I mentioned, there's 160 milligrams of caffeine in 1 cup. You would also need to know that 1 mole of caffeine is equal to 194.19 grams. That's just a fact of chemistry. You would also need to know that 1 mole of anything contains 6.02 times 10 to the 23rd molecules. That's Avogadro's number. You would have to convert from ounces to cups, so knowing that there are 8 ounces in 1 cup. And then finally, you would have to convert between grams and milligrams, and knowing that there are 1,000 milligrams in 1 gram. Now, that's a lot of information. So do not be intimidated by this problem, which is clearly a little more difficult than the converting of centimeters to meters. The best way to solve a problem like this is to just take it one step at a time. So we're going to focus on, we have 20 ounces of coffee. Now looking at these 5 conversion factors, these 5 relationships, the only place where I see ounces is right here, where 1 cup equals 8 ounces. Let's put cup on top and ounces on the bottom. So 1 cup over 8 ounces, we can cross off the units of ounces. And now we're looking for a relationship that involves cups. All right, there it is. There's 160 milligrams of caffeine for every 1 cup. And I can also cross out units as I go. Now, do we see any relationship that involves milligrams? So there it is. There's 1 gram for every 1,000 milligrams. I can cross off milligrams, and I keep going. Now I'm going to convert from grams into moles. And so this conversion factor tells me that there are 194.19 grams for every 1 mole of caffeine. I can cross off grams. And then finally, Avogadro's number tells me the number of molecules in 1 mole. So let's take a look at the math involved in this problem, which involved 5 different conversion factors. So let's do the math. 20 divided by 8, because that number is on the bottom, multiply by 160, divide by 1,000, divide by 194.19, and then finally multiply by 6.02 times 10 to the 23rd. If we do all of this math, hopefully we get on our calculator 1 times 10 to the 21st molecules. And you'll notice that I just rounded this off to 1 significant figure because the number 20 ounces had only 1 sig fig. Okay, that was a pretty challenging problem. However, conversion factors can be used to do simple problems as well as more complicated problems. So I'm going to give you some practice. Here's an opportunity to practice some one-step conversions and some multi-step conversions. Okay, there are 10 problems. Number 1, a one-step conversion. The atomic radius of cesium is equal to 298 picometers. Convert this quantity into units of meters. And you'll have to go back and refer to your notes. How many picometers are in a meter? If you don't remember, you can find it in your notes. It's going to be around 10 to the 12. So 1 trillion picometers are equal to 1 meter. But you can look that up in your notes. So convert that quantity, 298 picometers, into meters. That's a one-step conversion. All right, problem number 2. If you were to drive from Charlottesville, Virginia to San Francisco, California, the total distance traveled would be approximately 4,510 kilometers. Convert this distance into miles. And I give you the conversion factor between kilometers and miles. All right, number 3. A large container holds 2.22 times 10 to the 4th moles of water. What I want to know is, how many grams of water are in this container? And I give you a conversion factor between moles of water and grams. All right, number 4. We're still doing one-step conversions. suppose that the price of gold is $1,285 per ounce. If you won $11 million in a lottery, how many ounces of gold could you purchase with that particular amount of money? So again, you're going from dollars to ounces. And number 5, also a one-step problem. A student can solve 8 math problems in 5.6 minutes. If she needs to solve 36 math problems at this rate, how long will it take her to finish all of her math problems? So you're converting from problems, math problems, into time in minutes. Okay, so now we've done some one-step conversions. The next 5 problems are going to be multi-step conversions. Again, just take it one step at a time and look for relationships between units. Number 6. Platinum has a density of 21.45 grams per milliliter. The molar mass of platinum is 195.08 grams per mole. A sample of platinum has a volume of 1.53 times 10 to the negative 4 liters. Calculate the number of moles of platinum in this sample. All right, number 7. An aspirin tablet contains 1.09 times 10 to the 21st molecules of aspirin. The molar mass of aspirin is 180.17 grams per mole. Avogadro's number, 6.02 times 10 to the 23rd molecules equals 1 mole. Calculate the number of milligrams of aspirin in this tablet. All right, number 8. The volume of a balloon is 6,800 milliliters. The density of the air inside the balloon is equal to 1.225 kilograms per cubic meter. How many grams of air are inside the balloon? And I give you a conversion factor for cubic meters and liters. Number 9. The concentration of a sulfuric acid solution is 3.12 moles per liter. The molar mass of sulfuric acid is 98.08 grams per mole. How many grams of sulfuric acid are present in 15.0 milliliters of this solution? And finally, number 10. Under a certain set of conditions known as standard temperature and pressure, or STP, 1 mole of gas has a volume of 22.4 liters. Calculate the number of oxygen molecules in a sample of oxygen gas that has a volume of 4.8 cubic meters at STP. Remember that we are also talking about significant figures, so do your best to round off your final answer to these calculations to the proper number of sig figs. All right, good luck with unit conversions. Thanks for watching.